Um, Thanks a lot for coming to my talk. I will be talking about Python and Flask and REST APIs. So at the very start, I'd like to get to know you a little bit. So who here codes in Python? Okay, a few people. How many of you use the Flask framework? All right, just a few of you. And how many of you use REST APIs and write REST APIs in your daily life? All right, so for everybody who isn't using Python or Flask, this can be an interesting talk because I'm going to show you some really nice code, really clean code that you can write to create a REST framework with this language, maybe convince you to try it out. So, my name is Michał Karzyński, I work at Intel, I write a blog, and I had an occasion to write a book. I primarily write Python and JavaScript in my day-to-day work, and these are some of the things I'm interested in. But enough about me, let's get to the real meat of the matter. Since most of you raised your hand when I asked about REST APIs, I'm going to make the introduction short, but just to start somewhere. What are APIs? APIs are the way your front-end applications talk to your back-end applications. So in our case, the front-end application could be anything. You'll probably have a web application running in the browser. You may have a mobile application. And you'll have the source of truth for your application, your server. And in our case, that would be a server written in Python. And those things will talk to each other over the API. And in the examples I'm going to be showing you, they will be talking JSON to each other. And REST, well, if you know REST, then you know what it is. There's a lot you can say about REST. In fact, books have been written on it, but I can boil it down to one sentence. It's a clever way to use HTTP to build APIs. And the idea for REST was originally proposed by this person, Roy Fielding, who was writing his PhD dissertation on this subject. He was, in fact, working closely with Tim Berners-Lee, the creator of the World Wide Web itself, and they were considering how HTTP, the protocol of the web, can be used to power applications. And REST is what they came up with, or what Roy Fielding came up with. Since REST is based on HTTP, my presentation will be based around the HTTP protocol and the various parts of the protocol from which it is composed. So, as you all know, HTTP is a client server protocol wherein the client creates a request, sends the request over to the server processes it, and sends back a response. The request and response objects are composed of some similar parts, and you can see them outlined here. So the request has a method, typically get, post, put, or delete in case of REST. And there's the path where you specify what you want to access on the server, and there's the query of the request where you can specify additional parameters. Additional parameters can also be sent in the headers, which we typically use for cookies and content type negotiation between the client and the server. And then there's the body of the request, which in our case would be an object serialized in JSON. And then the response comes back with a status code indicating whether the request was successful or if there was an error, and also headers and a body. So in the presentation, we'll go through each of these later on. Well, how does REST use all of this? Well, it uses a set of conventions to access and create things on the server through the usage of different HTTP methods, accessing various resource types. So there are three main resource types outlined in red here. The collection resource represents a set of objects on your server, like books in this example, so it has a URL books, which is a plural noun by convention. And then if you send a GET request to this URL, you can get a list of your books, maybe a page of results. If you do a post to this collection resource, you can create a new book by sending a JSON formatted object representing a new book. And then if you already have a book on your server, you can access it by a URL containing an ID, and you can do a GET request to display information about it, a PUT request to update information on it, or a delete to remove it from your collection. There's also the controller resource type, which is sometimes controversial, but it's very useful if you want to do something which is external, outside of the scope of the normal create, read, update, delete operations. You may consider creating a controller resource which adds an additional verb to the URL of a particular item in your collection. And then if you do a post to that endpoint, you can perform some additional action on that object. So the meat of the presentation is not this introduction on REST, but how we can create REST APIs in Flask and an additional library called Flask-Restplus. So Flask is a Python micro framework. It was created by this man, Armin, who writes a lot of very good open source Python. And as it's a micro framework, the Flask itself allows you to easily create an HTTP server in Python. But other than that, it doesn't really give you a lot of additional tools. It's not very opinionated. It lets you do whatever you want. So you can extend Flask quite easily with one of multiple extensions that the framework can be equipped with. And the one I'll be talking about is called Flask-Restplus. This is the real hero of our story today. And it was created by this man in France. And it has a lot of functions that you can find very useful when making a REST API. It allows you to define your endpoints using very little code. It can automatically validate input coming into your API, the query parameters, the body of the request. It can all be validated automatically. You can also format the output that you want to send back to your clients as a JSON object using very little code. And you can turn your exceptions into HTTP responses, and all this with really minimal code. But there's one additional feature, the killer feature of Flask-Restplus, is that it equips your API automatically with documentation in Swagger and Swagger UI. And for those of you who haven't seen it, I want to do a short demo of what Swagger UI is. So give me a second. Okay. If you create an API with the code I'm going to show you in a second, and you come to the API on your server, what you'll get is something that looks like this. It's a web page that contains a list of all the API endpoints that you define. And these endpoints have documentation about the input and output of the endpoint, and you can even try them out and see if they're working correctly. So here in this case, I have a contrived little example of a blog. So the blog has categories, and when I do a GET request to the categories endpoint, I get a list of categories. I can create a new category by issuing a post request. So I go to the post endpoint, I see what the model I should specify is with a description of every field. I can even have a little example here of what the properly formatted JSON would look like. I can click there to enter it. I don't really need to provide an ID, so I will remove that. I will write something.
Excuse me, can you zoom in a little, please?
Is that better?
Yes.
Okay. Beyond that, we would, well, maybe that will still work. So here I can put in some JSON object. Once again, click try it out, and I will get a 201 response from the server. I can see the responses are documented here. That means that the category was created successfully. I can go back to the get endpoint, click try it out again. I'll see that the category was indeed created, and I can go to the delete method, provide the required parameter of ID, click try it out, and I'll get a 204 request, 204 response, which means that this was deleted successfully. And this makes the API very easy for the users to discover. All the documentation is in one place, and it's kept up to date automatically, because it's generated automatically from models that you use to define the API. You can even put some markdown into the notes of your methods, and that will be presented here with links and additional formatting if you want. So that's enough for the demo part. Now I'm going to talk about how you can, how this works and how you can do it. So first, how it works. The way this Swagger UI is created is through a specification called the Open API format, and that is a format of describing your API in a language that can be consumed by either the Swagger UI or other tools. So if I went to the URL /API/Swagger on my demo, I would get to see this description in JSON format. And because this description is in a standard format, there's a lot of tools that you can use together with this description of your API. The Swagger UI you already saw, that allows you to visualize and interact with the API. But there's also a tool called Swagger Editor, which allows you to describe your API before you even create it in the same language. And there are code generators, which, if you have a specification of an API written in this Open API spec, you can actually use that specification to generate some code for either a server or a client application. So this is an open source project. It has quite a few powerful members contributing or using the standard, so it's probably not going away, and I think it's worth checking out if you don't know. So let's get to Flask-Restplus, the library which you can use to create the APIs that I was showing off. We'll start with the request method, the request object, and we'll go through the fields one by one. So starting with the method, if you want to create an API resource, you simply create a class in your application, which is a subclass of the resource object, the resource class, and you add methods to this class, which correspond with the names of the methods of HTTP. So any of these would work and be converted into endpoints. And the documentation that you can put into each method is written as a doc string, so it's just written here in the code, and that will, if it contains markdown, it will be translated into HTML in the Swagger UI. Each of the methods you define becomes one of the entries in the UI, and for each one you get one of those forms that I was showing before. If you want to specify some URL parameters, you can use the API route decorator on your method or the resource, or actually on the resource class. So this was here on top, and each parameter that you put into these angle brackets will become a parameter of the method in the API. And you can specify the type, which will then automatically be validated by the Flask-Restplus library when the request is coming in. If the value provided in this space in the URL doesn't match the type you specified, you'll simply get a 404 error instead of reaching the method. The types are obvious ones, integer, float. There is a less obvious one called path, which is a string that can contain slashes, and you can even specify unique IDs in the URLs. These become then parts of the form, and the next part that you can specify parameters in is the query parameters. So to do that, you create a request parser object, and then you add each argument to this object using the add argument method, where you specify the name of the argument, the type, and whether it's required or not. You can even specify default values or a set of choices that the user should specify. And all this will be validated as the request is coming in. So in order to attach this validator to your method, you simply use this Python decorator, API expect, and that is enough to have the framework check the correctness of the arguments coming in. You can then use them directly in your method to get all the values from the request coming in. These also become part of a form. You will see this as a pattern here. And if you specify a list of choices that are legal, this will become a drop-down. Default values will appear as suggestions to the user on the form. Next part is request headers. And request headers can be outlined in the same way as request arguments. You simply specify a different location for that argument. And alternatively, you can use the API header decorator if you find that more readable, and attach that header requirement to one of your methods. Again, this becomes part of the form. Now, something a little bit more interesting. The request body that comes into your API is a JSON object, and you can use something called API model in this framework, which allows you to specify the fields of the JSON object that you expect to find. And this is in a way similar. You give each field a name, you specify its type, and you specify additional constraints that you want on it. For example, you can have a minimal value or legal values. And again, you use the API expect decorator to attach that to your method. And this becomes this slightly bigger form, the text area that you saw in the demo, where the model is described on the right, and you can even get this nicely prepared value that should work. It's just contains the right types for you. Now, these API models are interesting because they have additional flexibility through inheritance and nesting that allows them to be more powerful. And for example, here I have one API model that is that describes a category in the blog application. It's just a very simple ID and name. But I can have a second model, category with post, and created by inheriting all the fields from the category model and adding some additional fields. And in those additional fields, I can actually specify that this field should itself contain another JSON object. So I can use the nested field type for this. So I'm nesting a blog post here, so I'm expecting the request to come in with a valid blog post object in this field, and in fact more than one. So I can use the list field to specify that this is supposed to be a list of nested blog posts. So with that we have the request validation covered. Now I can get to the response object. And the response comes in with, must come back to us with a status. So the status is documented with another decorator, the API response decorator, which you can put on the class, the resource endpoint class itself, and then this will be a response code that applies to all the methods in this class, and I can have specific response codes for each method also documented here with a decorator. The way you return a specific status code in Flask is that you actually return a tuple of 2 values from your method, and the first value will be the object that will be serialized as JSON coming out of your API. In this case, I don't need any content, so there's a value of none. And the second return value is the status code. This documentation comes in the form of this little table in the Swagger UI that your users can review. Now I want to talk about the response body, which is analogous to the request body, but we're now going to use API models in a reverse way. So before we were using them to validate whether the incoming JSON is valid and matches the schema we're expecting. And this time around, we're actually going to use the same model to serialize the object that we're returning from our function as JSON. So one thing that can be quite helpful here is this attribute that you can specify on a field that will remap this value, the category ID value, from to another field in your object. So you can imagine that if you're working with an ORM and you have an object in your database that represents a blog post, it may be related to a category object through something called category, and that category will have its own fields. But all we care about is this one value, the category ID, so we can specify using this dot notation as a certain nested value from another object. And if we want, we can even write a lambda function here to do some more specific processing of the values that it wants to pull out to fill out the main field. So to attach this serializing model to the endpoint, we use the Marshall with or if we're expecting to return a list of objects, we would use the Marshall list with decorator. And that's all you need. And then you can return an arbitrary object from your function. It can be an ORM object, or it can be a data structure representing something. And only those fields that you specify in your API model will be returned to the user. So the user will see what you want, and you can even you can hide some things or change the formatting of some things this way. The last feature that I'm going to talk about is exception handling, which the framework also provides. And this is done through another decorator. This time called error handler. And you can give it a type of exception that you can be, you know that your application may throw. So for example, this is an SQL Alchemy ORM exception, and no result found. And if this exception were thrown anywhere in the code base and not handled correctly at the level of the method, it would be caught here. It would come to the error handler provided by the framework, and you can then turn it into a 404 exception in this case, maybe log something because it wasn't caught properly before, but the user would see a proper return message rather than a 500 error. If you don't catch any of the errors and they're not handled by your default error handlers, then inside of the developer's server that comes with the framework, that comes with Flask, you also get something which is an interactive debugger running in the browser. So if you arrive at an error in your API, you would get this page which shows you the stack trace of the place where the error occurred, and even gives you an interactive console where you can type in some variables and their values are, explore the place where the error occurred in the browser for some quick debugging. And all of these features come with very minimal boilerplate code. So this is a fully working hello world example of such an API that has all the features I outlined. You simply create a Flask app, you create a Flask-Restplus API object, and start defining your endpoints. So here's the resource class, one method, it simply returns something. And I can even run the debug server in the same 10 lines of code. So that's all you need to get started. But of course, in reality, you probably want to divide your code into multiple files. So I have the code of the demo that I showed on my blog. You can check it out for a more complex example. And that's the end of my presentation. Thank you.